Alright, students, let's look at this question here, which is on parametric equation taken from the year 2007, paper 1, question 11. This is actually from the actual H2 Math A-level national examination. So we are given the parametric curve of x equals to cosine square t and y equals to sine cube t. For this parametric equation is defined by this, and we are told to sketch a curve. I think sketching the curve is pretty okay. The first thing is to take note that this is make sure you limit the window setting here. So I think a lot of students would just forget to actually limit the window settings. Okay, so if you look at that, I'll just go to mode, change the parametric, and in this case here, what we're gonna get is actually just cosine t, so cosine t square, and then this case will be sine t to the power of 3. Okay, make sure you change the window settings. So the window settings is actually 0 to pi over 2, so I'm going to just put pi over 2 here, and I'm going to graph it. So obviously I'm going to zoom box to the area where I like to use zoom box. So you just click and drag to this area here in the middle, where the graph is, the action is going on there. So this is the graph that you're looking at. Okay, so just plot this graph, should be fine. So once we sketch this, just take note, do we need to, so usually what I'll say to students is just check the extreme, the lower bound and upper bound of the, what they call it, the domain there. What we're going to do is actually just key in trace, press 0, and you will get 1, 0 here. So this is pretty okay. We get 1, 0, 1, and after which I'm going to just put in pi over 2, trace pi over 2, there'll be, pi over 2 is 0, trace 0 will be 1, 0. Sorry, so this is 1, 0. Okay, now the good thing about parametric equation is good if you just know that which parameter correspond to which point here. So I usually will say just put this as t, trace 0. This is t pi over 2, and know that this point corresponds to t equals to 0. Okay, it's very important to know what is the parameter acting behind the point. Okay, so let's look at part 2. So for part 2, what we will get is actually sketch a tangent to the curve at cos theta square theta sine cube theta meets xy. Okay, the tangent to the curve. Okay, great. So if there's a tangent here, they say that if there's a tangent here to this curve here, I'm not sure what point it is, but if say there's a tangent here, you have a point here which is actually, okay, this is a tangent, right? This tangent here. So this point here is cosine square theta and sine cube theta. Now this would mean that the parameter now is t equals to theta. Okay, at this point here, it cuts the x-axis at q and y at r. So this is q and this is r. I think shouldn't be a huge problem there. Show that the area of triangle O. Okay, first of all, if you want to show the triangle here, you need to find OQR. Is quite straightforward. You need to find the coordinates of Q and R. So in other words, we need to find the equation, the tangent, right? The tangent equation of tangent. So dx dt first. We find out we need to find dy dx. So just find out what is dx dt. So dx dt will just be twice of cosine t to the power 1. Differentiate cosine is negative sine t. This is dx dt. Then y is actually sine t cube. Okay, then after which dy dt will be 3 sine t square. Differentiate sine is actually cosine t. Okay, so that's it. So dy dx will be dy dt divided by dx dt. So this is 3 sine t square. Maybe I just too many brackets here. So this part here will be, so then we could slowly cancel it out. This case here, cosine and cancel this y sine. And what is left behind is actually just minus 3 over 2 sine t. Alright, that's pretty okay. So the parameter here is actually theta. So we need to find out. So this case here, equation of tangent. Okay, so when t equals to theta, we know that the point is, we were given the point. The point is this, right? This is your x and this is your y. X equals to cosine square theta and y equals to sine cube theta. So this case here, equation y minus y1 minus y2, m x minus x1. We just want the equation of tangent there. So y minus sine cube theta, m would then just be negative 3 over 2 sine theta. M is just dy dx when t equals to theta, which is negative 3 to sine theta. Okay, there's a gradient. Then this will be x minus cosine square theta. All right, so this is where we are able to find the point of Q and R. So to find point R, we don't really need to simplify this. So I'll say point R is when x equals to 0. This will just be y equals to y minus sine cube theta, also minus 3 over 2 sine theta, positive cosine square theta. Then this case here, what we can is y minus 3 over 2 sine cube cosine square theta plus sine cube theta. Alright, so at point Q, am I right? Point Q is when point Q is when y equals 0. This would then be negative sine cube theta equals to equals to 3 over 2 sine theta x minus cosine square theta. Okay, this will be 2 over 3 sine theta and x minus cosine square theta. So x will just be 2 over 3 sine square theta plus cosine square theta. Now this is your coordinates. So r is this is your r here. I'm really lazy to write the whole thing here. So but anyway, this is your yr. So here will be your yr here. Let me just label this as yr. And here is your xq. Okay, this will be xq here. Okay, so this is xq, say. Great. So the area that you're looking at would then be the area triangle. So area of triangle OQR half times YR times XQ. Right? So I'm going to just multiply them. I'm not sure what I'll get, but if you were to if you were to get it, it would be great. So this would be 2/3 sine square theta plus cosine square theta. Seems a bit promising. So we need to show that is 3. So I'm going to bring out the half out. Factorize the half sine theta out from the first one. So this will be 3 cosine square theta plus 2 sine. Okay, so I factorize the okay, then similarly with the second one, what I'm going to do is actually just factorize the we need sine square theta, so factorize the third out. a third out, right? 1/3 out. So this case here be quite okay. I think this is 1/3. Then we get 2 sine squared theta. There you go. Okay, then after that we just multiply them. This will be 1/4 times this is 1/12 sine squared theta. 3 cosine squared theta plus 2 sine squared theta square. Okay, so I think it's pretty okay. 6 marks, yeah, pretty reasonable. I think all the steps here are pretty okay. So if you have any question, please do let me know, and let's look at the subsequent part. So let's look at the next part. We want to find the area under the curve, which is whole thing here. I think it's pretty okay. If you want to find the whole thing here, just make sure that you know that we need to write in Cartesian form first before we move on, right? So for part 3, required area will then be the integration of 0 to 1, I believe, 0 to 1, and y dx, right? And then we know that y, now we need, our goal here is to change this to parametric form. So we know that y is equals to sine cube t, and dx, okay, dx dt we found, right? Dx dt is actually, dx dt is, where's our dx dt? Here, 3 sine t, so I'm going to write this down. Dx dt is actually 2 cosine t minus sine t. Alright, dx dt. Oh, that's dy dt. Dx dt is this, right? Great. So, now take note, this case here, dx will then be 2 cosine t sine t. So of course, please erase this away. If not, actually, I think it's fine, but if you don't allow to write this, then just make sure that you just erase away. So now our whole goal here is to change this to parametric form. So sine cube t dx dt, which is actually minus 2 cosine t sine t dt. Okay, so I just replace the whole thing here. Then what we need to do next is essentially this is the important one. This is where the careless mistake comes in. If you change your dt, just make sure this boundary condition change as well. It should change to the parametric form, parameter. So x, when x is 1, that's why this labeling is important. When x is 1, right, for the curve, we know that t is 0. So this one will correspond to 0 here. And when x is 0, it will correspond to pi over 2. You could just quickly write it down. So you just, if you trace pi over 2, you get here 0, 1, right? So this is pi over 2. That's how you change the boundary there. Okay, so this case here, once done, what we can do is actually just this is 0 pi over 2. Then I'll just bring this out. So this is, I'll bring the negative 2 out actually. So this will be cosine t sine the power of t dt. Great. So because we are told to show this, do you see this negative here? We just need to absorb it up. Then this will be pi over 2. We can just swap down and up. Okay, cos negative abfx dx is equals to abfx dx. Take note. Okay, so this case here will be cosine t sine 4t dt. So this is shown. Of course, if you can't show this, is fine. Just make sure you do the subsequent part, which is using the substitute u equals to sine t. Okay, so du dt here will just be cosine t. So I'm going to just replace this. So when t equals to pi over 2, u equals to sine, just replace this, sine pi over 2. Sine pi over 2 is actually just 1, right? Yeah, then when t is equals to 0, u is equals to sine 0, it's just 0. Okay, so just take note. Same thing, when we change, we need to change it. So when this is 0, it is 0. And when this is pi over 2, this is 1. So this is 1 and 0. Cosine t is actually, cosine t is Okay, we're gonna just change this cosine t. Cosine t, sine t will be u to the power 4, then dt. So this is actually just u substitute method, cancelling method. You will get cancel away this, is fine, and you get this as u to the power 4 du. So this will just be u5 over 5, 1, 0, and 2. So this case will be just 2, 1 over 5. So it's 2 over 5 square units. All right. So that's how we do this question here proficiently. If you have any questions at all, please do let us know. Keep practicing, and I will see you in the next question.